The two tennis balls hit the ground at the same time because they start from the same height and have the same vertical velocity when they land. They have the same vertical velocity when they land because they start with the same initial y velocity, being 0, and both only have gravity acting upon them. The horizontally thrown ball also has an additional horizontal velocity component. The velocity in the x direction does not affect the acceleration in the y direction. The only thing it affects is the additional horizontal distance it has to move and not the time it takes to travel vertically. Since speed is defined as the magnitude of the resultant velocity vector, the thrown ball is moving faster when it lands. Because the horizontally thrown ball is moving faster, it offsets the time it takes to move in the horizontal direction, so they will end up landing at the same exact instant.
A projectile is an object that is acted upon only by gravity. In reality, air resistance plays a role, but similarly to free fall, we neglect air resistance unless told otherwise. Projectiles are objects launched at an angle or horizontally. Projectiles move in parabolic arcs. Projectiles launched at an angle have motion in 2 dimensions. The object is in free fall, which compensates for the y direction and also has displacement in the horizontal direction. The x velocity vector must be parallel to the x-axis, and the y velocity vector has to be parallel to the y-axis. In essence, we have broken down the total velocity into 2 perpendicular vectors.
For our example with my shoe flying through the air resistance is going to be negligible. Near the surface of the Earth, objects accelerate downward at a rate of 9.8 meters per second squared. It is called the gravitational field strength. As you move further away from the Earth, the more the gravity decreases. Gravity affects all objects on Earth. The net force on an object in the air is mg, or mass times the planet's gravity. The net force is what moves the object in a parabolic motion.
The difference between horizontal and angular launch is the horizontal launch is half of the full parabolic motion presented in the angular launch. The projectile motion launch will end when the projectile motion has traveled its full height vertically. We know that the projectile has an initial velocity in the x direction. Create a horizontal table with the x variables, which will consist of a consistent x velocity, meaning the velocity initial and the velocity final will have the same value. The acceleration in the x direction is always 0. In the vertical motion table, you will have the height at which you dropped the ball, delta y. Because the object is thrown horizontally, its initial vertical velocity is 0. Its only velocity is in the horizontal direction, and that acts independently to the vertical motion. Acceleration will be 9.8 meters per second squared. With all this information, using the kinematic equations, you will be able to solve for any variable that is asked for. For objects launched at an angle, you must find first, break up the object's initial velocity into x and y components of the initial velocity. Then, use the components of initial velocity in your independent horizontal and vertical motion tables. For launched at an angle, the object will travel the maximum horizontal distance with a launch angle of 45 degrees.
The horizontal and vertical components can be broken down using v equals v initial cosine theta for the horizontal velocity and v equals v initial sine theta for vertical initial velocity. We can now use v initial velocity in the x direction and v initial velocity in the y direction for our initial velocities in our independent x and y motion tables, respectively. If you look at the projectile at the top of the trajectory, the vertical velocity is 0. With that conclusion, the time will be halved. When looking at the full parabolic motion, the time it takes to complete its path will be double the value it takes to reach its maximum height. The acceleration in the y direction will be 9.8 meters per second squared, similar to a horizontally launched object. The velocity in the x direction will be constant throughout the trajectory. V initial in the y direction equals v final in the y direction, when the projectile is at the same height from where it was launched.
A reference frame describes the motion of an observer, the most common reference frame being the Earth. However, in our example, their speeds are being measured relative to each other. For relative motion, we assume we're in an internal, non-accelerating reference frame. Gotcha. Okay. Consider the slow ball on the left to be ball A and the fast ball on the right to be ball B. Ball A is traveling at distance over time, A meters per second, and ball B is traveling at distance over time, B meters per second. This was calculated by measuring the distance the ball has traveled and setting up a proportion, using the time it took to go that distance. To find the velocity of ball B relative to ball A, subtract the velocity of ball A from the velocity of ball B.